Okay, I'm going to work through some of the problems from exercise 6.3, Q1 and Q2. See what we have time for. I wrote out the even ones. The odd ones are due for homework. So we'll do some of the even ones. Now, the important thing to remember, and I put this note up on Blackboard, is the sentence you're given is not a premise. It's a conclusion that you have to derive using no premises. Okay? So when you derive a conclusion from no premises, that proves that the conclusion is a tautology. Remember, tautology means always comes out true. So it's true no matter what, and that means it's provable with no premises. Similarly, if you can derive a contradiction from a sentence, or if you can well, we'll get to Q2, but if you can prove a sentence is a tautology by deriving it from no premises, right, then you can prove that its negation is a contradiction. Because a tautology means always true, contradiction means always false. So Q1 has to do with proving tautologies, Q2 has to do with proving contradictions. And again, remember, this is our conclusion, not a premise. So the question is, how do we prove anything without a premise? We can't do anything. Well, that's why for these kinds of problems, you have to use one of the methods that allows you to make an assumption. So that means conditional introduction or one of the negation rules. Because it's not possible to literally derive a conclusion from nothing because you need something, right? So the something we get is by assumption. And the rules that allow us to make assumptions are conditional introduction, negation introduction, and negation elimination. All right. So if we look at number 2 here, the conclusion is F conditional F or G. It's a conditional, so we should use conditional introduction. So we'll tab over and we'll assume F, and we want F or G. Okay. So remember, this assumption is always going to be the antecedent of the conditional you're trying to derive, and what you want to get is the consequent of the conditional. All right. And this F now we can work with. We can work with it because it's an assumed premise. It's not to say it's true, but we can use it as a premise. Oops. So now how do we get to F or G? Simple. We do a disjunction introduction of 1. So we assumed F. We derived F or G. So now we can come back to the original scope line. If F, then F or G by conditional introduction 1 through 2. So that proves that this sentence then is a tautology. All right. So we derived it from no premises. Now, this is an assumption, remember. It's not a premise. We're not stating it as true. It's just an assumption we make. So we can still say we did derive this conclusion from no premises. Right? But again, you can't literally derive something. You need something to start with. So we start with an assumption. And that means we're always going to have to use the rules that allow us to make assumptions for these. Okay, so let's do 4. I'm gonna tab out. Okay, so 4 we're trying to get a biconditional, right? Remember, a biconditional is the conjunction of two conditionals, right? So if we get these two conditionals, we can use the biconditional introduction rule to get our conclusion. And so we'll do conditional introduction to try to get each, right? So we start with an assumption P want P. Oops. So now we need to get P down here. How do we do that? Simple, we can just reiterate line 1. That gives us if P, then P by conditional introduction 1 through 2. Now we also need again to get if P then P, but since we already got it there on line 3, we can just reiterate it again on line 4. Now we can do P by conditional P by the biconditional introduction rule of 3 and 4. Okay, so again, we proved this with no premises. We started with an assumption. We use that assumption to derive if P then P. We reiterated, so we had both halves of the biconditional. So then we use the biconditional introduction rule to put those together to get our conclusion. Okay, number 6. Again, our conclusion here is a conditional, so we use conditional introduction. So we'll assume S, and we want V and not V conditional W. Right? Again, you always assume your antecedent, and then you want to get the consequent. Okay. But now the thing we want is also a conditional. So we can indent again. Our antecedent is V or not V, and we want W, the consequent. So now we have two assumptions. We have S up here, we have V and not V. And we want to get to W. Alright. Now notice W doesn't appear anywhere. And the one rule that allows us to introduce a sentence that doesn't appear, or a rule that does that, is the disjunction introduction. But first let's get V and not V by themselves. So this is conjunction elimination of 2. Not V by conjunction elimination of 2. Now we can get V or W by disjunction introduction of 3. So we had V up here. Disjunction introduction tells us we can, if we have a sentence like V, we can put that into a disjunction with any other sentence. Because if V is true, this whole disjunction is going to be true. Now we can get W by disjunction elimination of 4 and 5. 5 is a disjunction. 4 is the negation of one of the disjuncts. That gives us the other disjunct. So that's what we wanted, right? We wanted W. So this is done. We get if V and not V, then W. That's by conditional introduction 2 through 6. Right, 2 was our assumption, 6 was our consequent. So lines 2 through 6 give us this conditional. And now that was what we wanted, so we get our conclusion. If S, then V and not V, then W. And that's by conditional introduction. Our assumption was on line 1. Our consequent was on 7, so 1 through 7. So there's not really anything new here as far as applying rules or new rules or anything like that. The main trick here is that since you have no premises, you have to start with something that gives you an assumption. So conditional introduction, or like I said, one of the negation rules. Okay, so let's do the last one from Q1. Okay, so again we have a conditional, so we'll indent, we'll assume the antecedent, and we want not B, then not G, conditional B. So that's our assumption, the antecedent. What we want is the consequent, all this stuff here. But again, what we want here is also a conditional. So we can use the same strategy. Assume the antecedent, not B, then not G, and want consequent. So now we have two assumptions to work with. We've got G here, we've got not B, then not G. We want to get B. What can we do? Well, if we had not G, we could get not B, which with the double negation rules could change into B. But we can't do modus tollens here until we do the double negation step. So we can go not G by double negation of 1. Now we have a conditional, and we have the negation of the consequent, so that gives us the negation of the antecedent. Modus tollens 2, 2, 3. Now that gives us B by double negation of 4, and that's what we wanted to get. So this one brings us back. We get not B, then not G, then B. By conditional introduction, our assumption was on line 2 here, and our consequent was on 5, so 2 through 5. And now that was what we wanted here, so we're finished with this one. G, conditional, not B, conditional, not G, conditional B. And that our assumption here was on line 1, and our consequent was on line 6. So conditional introduction 1 through 6. Okay, so again, we didn't have any premises, but we used conditional introduction to get an assumption, to generate two assumptions. We use those assumptions to ultimately prove this sentence. So this sentence now is true, and it was, since it was derived using no premises, it is a tautology. Okay, we're running out of time on this one, so I'll stop here and I'll post another video where I do some of these problems from Q2 where you have to show that the conclusion is a contradiction.